So, because some of this material can get a little bit dry, this is going to be brought to you with the help of classic programmer paintings. If you haven't seen this Tumblr, you should check it out. It's very, very amusing. It's just a load of classic oil paintings, but with the titles changed to something to do with software development. Some of them really nicely done. What I've done is I've just taken some of the paintings without their titles, so you'll have to read something into it yourself. But that sort of just changes the tone a bit. Also, of course, with the help of Twitter, got a few tweets that I think are appropriate to do with testing. So, let's get started. And I wanted to start with just a little bit of, in general, about testing, because not everyone's always on the same page. And in fact, I think all of us can get something from this. So the question is, why do so many people, well, first of all, not write tests at all? Still plenty of people that don't like writing tests, don't see the point in it. And we can include probably everyone if we look at that second part. We don't write enough tests. I mean, when was the last time you finished a project, you sat down and you thought, yeah, I wrote exactly enough tests for that? I don't think I've ever had that. So we know we can always write more tests, we know we should, but something stops us. What is that? And it's not a trick question. I've put some candidate answers up here, pretty obvious ones. It seems like extra work. I've done the job, I've written the code, I know it works. So why do I have to do extra stuff just to prove that? And closely following on to that, already checked it manually. Because that's what we do, isn't it? We write the code and then we just check that it actually did what we wanted to do. So why do we have to then check that again? And we don't hear the last one quite so much anymore. Still sometimes comes up that we have a separate team for that to do the testing. In fact, this is sort of coming back in again now. We've invented this role, developer in test. So we actually have developers whose job it is to do the testing. So it's not just testers anymore. But no, usually it's just that we think it's extra work. And one of the most endearing properties we have as programmers is that we're lazy. We don't want to have to do unnecessary work. So that's a good thing, really. But here's the thing. We said that we somehow tested our code manually. And if you think about it, this is really, for many of us, what actually got us into programming in the first place. This idea that we can write some code, this very abstract thing, and then we can see it do the thing that we wanted it to do. That gives us a buzz, makes us think, yeah, I want to go on and do the next thing. So that's actually fun. So it turns out that manual testing, in that sense, can actually be fun, if you think of it that way. But with one important caveat. That's only the first time you do that testing. And here's where it all breaks down. Because we don't actually repeat our test enough. Once we've actually written our feature and we tested that works, we move on to the next one. Do we go back and test that it still works, that we haven't broken it? And that's really where that strategy breaks down. Because it is very tedious and repetitive work to go over and keep testing and testing and testing. And we're just not built for that sort of thing. It's also very repetitive. And, well, you get the idea. But who's really good at that sort of work? Computers. If we can write code that will do that testing for us, automate that job, that's taken advantage of the very power of the machine that we're programming in the first place. So we're winning on all angles. So why don't we do that? Well, let's flip this around and have a look at it the other way. Why should we write tests in the first place? So I'm going to break this down into basically two broad areas. Correctness, so actually checking that it does the right thing, but also that second part that we talked about. Once we know that it is working, does it stay working? Do we introduce any regressions? And it's really important to distinguish between those two roles, because we can actually place different value on the test depending on which of those roles it's fulfilling. This is particularly important if we're doing TDD and we're writing tests before the code, because what happens there is initially that test is going to play the role of just correctness. It's going to tell you when it's actually starting to do the thing you wanted it to do. And once it's achieved that, then it flips into the regression role and Whoops, jumping ahead too much. And that it only is playing that role from that point on. And the reason that's important to keep in mind is because we'll often write tests for testing some sort of low-level feature that's not necessarily tied to your high-level requirements. And we'll write the tests as part of our, driving our code through tests. But once that feature's in, those tests can actually hold us back. They can become brittle, and they can easily break and become a liability. And when that happens, we shouldn't be afraid to get rid of those tests. We'll sometimes spin them out, but we shouldn't feel that because we've written the test, they must stay there all the time. So it's very important to distinguish those two roles. So I hinted at the next step, why should we write tests first? I'm a strong believer in TDD. Not always appropriate, but very often is. Why should we do that? I sort of hinted at this idea that codifies expectations before we write the code. And the reason this is so significant is because we have these different mental modes. When we're thinking about the design of something, then we're in one mental state, and we have access to different mental resources as a result of that, with this very sort of design frame of thinking. But then we start implementing it, we switch into this implementer's frame of mind. We've got a very different set of mental resources, and we start to get distracted by different things that are not necessarily to do with what we actually set out to do to begin with. So if we write the test when we're in that design frame of mind, we codify that at that point, and that frees us up when we're implementing to not have to worry about that. Now that the test framework has got our back, that's playing that role for us. Frees us up to get distracted, and then we'll know that we're getting off track. But that's quite important. But the other side is something you hear a lot of from TDD practitioners, that our test can guide our design by exerting this design pressure on our code. And what we mean by that is it doesn't automatically make our code good. But if we're ignoring certain important design principles that are quite hard to get right otherwise, it will tell us by making it really hard to test. If your code is hard to test, then it's probably because you're violating some design principle that you need to consider and try to build that in. Know what those principles are and how to use them. But it will keep you honest in that sense. That's why we say it exerts the pressure in that direction, will guide our designs. So, we're asking the question, why do we test? There can be a very to bugs coming as a result of not testing enough. Of course, no matter how much testing you do, you can never get rid of all bugs. But it's worth just for a moment having a look at some examples of very real costs associated with bugs. So the Mariner 1 rocket was destroyed due to a code error in 1962. Probably the first recorded example where we have a monetary amount attached to a bug. Now in this case, technically we couldn't have caught it with a unit test because it was while the code was being transpiled to punch card. But it was a software bug that had an associated cost of about 135 million. In today's money, although I think that figure was 10, 15 years ago, so maybe more now. So quite a lot for one bug. Sticking with rockets, Ariane 5 in 1996, so a little bit more up to date, self-destructed due to an integer overflow. Now the worst thing about this was that was in code that wasn't even part of that mission. It was left over from a previous mission. So it was down to code reuse and then not testing that. And in fact, it was because it was being used in conditions that the previous mission just didn't even have to concern itself with. And the resulting cost was over $370 million. So we're going up. You know who this guy is? This is Tony Hoare, who confessed to his $1 billion mistake, which was null. He invented the null pointer or null reference. He admitted to it, confessed. And he also estimated that it's probably cost the industry, and this was, again, some years ago now he said this, in excess of $1 billion. Now, again, you couldn't have caught this with a single unit test, but we've certainly written a lot of unit tests as a result of this. So it's definitely very relevant. You can see these figures are going up. So the final example, it's actually a study from 2002 I did find something slightly more up to date, but this one was the one I'm going to quote from. The few choice quotes. First of all, software bugs are costing the US economy, so just the US, an estimated $59.5 billion every year. Later it says that improvements in testing could reduce this cost by about a third, or $22.5 billion. So we said testing won't catch all bugs, but they've estimated it can make this difference. And then the general consensus seems to be that the current state of the art with respect to testing is poor and can be sufficiently improved. It's interesting, this was in 2002, so about the start of the sort of agile revolution as it came into the mainstream. It could be argued that maybe the current state of the art with respect to testing has improved in the intervening years, but by how much? That's why I was looking for another study, and it doesn't really seem to have impacted those figures very much. So we're talking huge amounts of money as a result of software bugs that could be caught by better testing. So just from that perspective alone, it's definitely worth doing all that we can to make that, increase the quality of our testing. So I don't think we had enough cat pictures at this point. I'll leave you with that one. Now, just to recap, we know that we need to write tests, but it seems like too much work. But we also know that we need to do it anyway. So first of all, we need to realize that it's actually going to be less work in the long run. Like we said, we really should be testing our things, our code, not just the first time we run it, but multiple times, every time we make any change. It's going to be less work if we get the computer to do it. But it also means that our testing environment, particularly our test frameworks, need to be easy to set up and easy to use, offering the minimum possible friction. So we're finally getting to introducing the subject tonight, because this was a situation I was in some years ago, looking around for a test framework and just meeting all this friction. So much work just to get up and running with a test framework. But I just decided to write my own, because how hard could it be? And here we are 7 years later, and I've only just got to version 2. So obviously I'm talking about Catch. So to give you an example of how easy it is to set up and running, I'm going to give a demo. Now, I should say, so this talk is about Catch2, and I've previously done other talks about Catch in the past where I've gone into more detail with more demos just to introduce Catch. So I'm just going to summarize it this time. So, yep. So we've got a C line here, of course. Start a new project. And let's call it Hello Munich, because I'm feeling creative. So like any IDE, it's given us just a hello world. That's probably not going to be big enough to read, so let's increase the font size a bit. What am I looking for? Font. Does that look big enough at the back? Good. Okay. So we're not going to be using the hello world. What we're going to do is to include Catch. Now we haven't actually got Catch yet. So this is real raw TDD. So we've got a compiler error because we can't actually include that header. If I do go to compile it, you'll see that there. So I've prepared the header over here. But actually that's all we need, just a single header. So we can grab this from GitHub. It's only one extra step. I'm just going to drag that into the project there. So that one will compile, but it doesn't link. And the reason is that we don't have a main. So we can ask Catch to define main. And there's other ways to do this, but this is what we need for now. So that should now compile and link. And you notice it takes a few seconds. Actually, it's about 7 seconds there, because it's actually built the whole framework. But that's now a complete running application. Doesn't do much, but it is complete. So now we should write a test. So I'm going to put this in a separate file. Now, if you've used Catch before, you may or may not know that this line here not only defines main, but actually compiles all of the implementation of Catch into this translation unit. So that's why it took 7 seconds. But in all the other files, it will only be acting like a header. So it'll be much faster to compile. So if you have long compile times, that may be one reason. So there you can see it just took less than a second to build that. So what I've done here, I've just written a test case. I haven't given it a name. It's completely anonymous, which is occasionally useful. And there's no actual tests in there. So let's do this one at a time. So this is one of the assertion macros, require. And I'm just going to say that 6 times 9 is equal to 42. You may or might not get the reference. So let's see what that does. And we can see that it's failed. Now this is interesting. So it's given us the assertion as we wrote it here. And I don't know if you can see that there because the colour's not too good on this screen, but it's actually telling us what the values of the left-hand side and right-hand side of the expression actually were. It's broken that down for us. If you've used other test frameworks, you may have been expecting to use a require equals, require not equals, and had to split the expression up, but it's done it for us by breaking it down using expression templates. So that's the first feature worth noticing. Now we didn't give it a name, so if I come up here, you can see it's just called it anonymous test case. And again, if you've used other test frameworks, you're probably expecting to have to write the test name as a legal identifier, because it'll be a function or a method name or something. But in Catch, it's just a string, so it's completely freeform. So I can use spaces and commas and other punctuation, like that. So if I run that again, we see our test name. So you can write very descriptive test names. So that's nice. Okay, now the other thing worth noticing is, because we're running this in C-line, we can take advantage of C-line's built-in Catch integration. So I can just set up a Catch config for that. Call that test runner. If I run that now, you'll see it comes up in this tree view here, and we get our breakdown over here. You may prefer that. Now, the test is failing. I'm pretty sure that my maths is right here. That 6 times 9 does actually equal 42. What I'm missing is the correct number base, of course. It should be in base 13, like this. Now, we haven't written base 13. Save a bit of time, I've got a snippet prepared. So that will convert to base 13, we'll return a string. And with that should now all work. And now it'll test accurately. So before I move off of this, if I run this from the terminal, what do we call it? Hello, Unique. So you see the same result there. So when all the tests pass, you just get a very, very brief summary. But you can override that and get the output, the full output anyway. We can also list currently available tests, so you see that test name. And of course, we can get access to the full help, which we won't go into. We will actually come back to this a little bit later. But for now, that's introduced a few things about Catch, and you can see how quickly it is to get up and running. So I'm going to go back to the slides. Where did that go? There we go. Right. So I'm going to summarize some of the other parts of Catch that I've previously given demos on. So this is a more full example of a test case. First thing to point out is, I think I can use this actually. Is it going to work? Nope. Oh well. Spent a lot of money on that as well. Okay, I'll just point it out. So you've got the test name up there with the free-form string, and they've got the second argument in square brackets. You can have any number of tags there. And while test names must be unique, so you can uniquely identify your test, the tags don't have to be, so you can group tests together with tags. You can actually combine them in different ways. So that can be quite useful. Then we've got these sections. And they take a little bit of explaining, but they're actually really powerful. So again, many other test frameworks will have a feature called fixtures, where you'll write a test class, and the test class will have multiple methods, each method is a test. But then you can have members of the class that will have some common setup. You'll have a setup and a teardown, or the constructor and destructor. That works for splitting out some of your common setup, but it has a number of limitations. First of all, you can only do that for one level deep. But secondly, it means that you're separating your code that you want a common setup from the rest of the code under test, which can be a little bit unnatural. And you can often want to do things on the stack that you're prevented from doing that way as well. Section solves all of these problems, and a few more. So you just divide your test up into subtests, if you like. And the way it will work is you come into the test case the first time, you'll execute the common setup at the top. You go into the first section, start executing that. But when you come out, you then skip over the rest of the sections. It then goes back in again, execute again from the top, the common setup code, but this time skip over the first section and execute the second one. But the second one has a nested section inside that, so we'll execute that as well. And then we'll skip over the remaining one. And then the third time, we'll skip over the second section and execute the third. So each leaf section will be executed effectively in isolation from the top of the test case. So you get the full stack all the way down. So you can have multiple levels of common setup that way. You can take this further. There are additional macros that map on top of sections that give you BDD style syntax, given, when, then. So scenarios like test case, and then each given, when, and then is just a section. But that means now you can say, in this case, given an empty vector, and then you have the code for the empty vector, and even verify that. When it's made larger, make it larger. Then the size and capacity go up, then you verify that, and so on. So you have the natural language description of what you're actually doing right alongside the code that makes that happen. And the best part is, if one of these things fails, here's what the test name looks like. This is actually the test name. So instead of just some C++ identifier, you have a full scenario description, all nicely formatted as well. So I quite like that feature. So, haven't had enough Twitter, so. And talking of integration tests, Catch is not just for unit tests. You can do integration testing as well, of course. And one way that Catch works quite nicely with that is it's often really nice to be able to separate your integration tests out from your unit tests. So when you run your test executable by default with no arguments, it will just run all your unit tests. What you do is you effectively hide your integration tests by using a special tag, just a dot. It has a dot tag, it won't be part of your default run. But then you can also give it another tag, integration, and then you could just say run all the tests tagged integration. It will run those. So you can separate those things out quite nicely. Another oil painting. This is not actually from the classic programmer painting site, but it is a classic oil painting. This is Monet, of course. This was painted in 1899, so well over 100 years ago. Whereas this photo of the same bridge was taken just this summer, on my way back from holiday. My family on the bridge there. And the reason I put this in is, as well as just a good excuse to get my family photos up there, it also just illustrates the passage of time. Because now we're going to talk about what's new in Catch and Catch2. So yeah, a bit tenuous, I know. So before we get on to Catch2 and what that is, I wanted to bring up to date on Catch itself, because If you've seen some of my previous talks or used Catch for a while, you may not be familiar with some of the new features. I'm not going to go into all of these in detail, so I've just put some bullets up there. I'll dig into matchers a little bit. And then reporters and listeners, it's worth summarizing. So, like many test frameworks, Catch has a modular reporting framework. So, what we saw earlier was the console reporter. So just the default to output to the console. But you can have an XML reporter, a JUnit reporter. They've been there since day one. But you can provide your own. Catch now has a number of additional reporters bundled with it, including Team City reporter, of course. But then I've also added this listeners interface. It's actually the same interface as reporters, but it's more intended for just listening to events in the code. So you can write code to respond to the start of every test case, for example, or the start of every section, or the end of every section, and just inject your own code there. So that can be useful. And I also mentioned performance. This applies to both compile time and runtime performance. Particularly runtime performance was really not a goal of Catch originally, but over the years it's become increasingly important. So there's been a lot of low-hanging fruit to target there, so definitely working through that. But compile time performance as well. It's always been a bit more important, but a lot of people are finding that very large test code bases are slow to compile, so we're working through different approaches to that. That's an ongoing work. So that's Catch 1, up to date. I wanted to talk a bit more about matchers. So if you don't know what matchers are, we may have heard of Hamcrest before. That's a very popular Java matchers framework, I believe, with ports to other languages. But all a matcher is a way of writing custom fine-tuned assertions that are also composable. So what we mean by that is, well, here's a good example. We introduce it using the require that or check that assertion macro. We have the thing that we want to match against, and then the matcher itself, along with any arguments. It sort of reads fairly fluently. So in this case, require that this string contains some substring, or starts with a substring, or ends with a substring. So these can be much more fine-grained and custom than just the equals, not equals, and so on. So as well as the custom aspect, I mentioned composability. So here we're saying if it contains this string or this string, and also contains another string, so you can compose them together however you like using these logical operators. As well as string matches, there's also some vector matches bundled. So you can check whether one vector contains a particular element or contains another vector. And we've also just added one where it will check that without respecting the order. So the vector may come in a different order, but it will still match. And we'll be adding some more matches like that. But the matches framework itself is also extensible, so you can write your own matches. So here's an example of a custom matcher. Let's try this again. Is it going to work now? Such a shame, it's really useful. So all you do is you write a class that derives from Catch matcher base, templatized on whatever you're matching against, in this case special exception. You'll give it a constructor to just capture any arguments, so it doesn't have to be the same type, in this case it's an int. And you've got two overrides of virtual functions. Match just takes the thing you're matching against and then does whatever you want to check that. So in this case it's just checking a particular field on there. And then describe will just return a string describing what the matcher does, including whatever argument it caught in the captured in the constructor. That's all there is to it. Looks a bit more complex on the slide, but it's very simple in practice. And then you can use that exactly like all the other matches. But the reason I chose an exception matcher here is because there's also an additional macro you can use, the throws matches form, that will check that whatever the expression is not only throws something, it will check the exception type and then pass it on to your exception matcher. So you can actually do some very fine-grained exception checking using your own matcher types. So that's matchers. So let's see what's new in Catch2 then. So Catch2 is the new version of Catch. It was released about a month ago now, but it's sort of been in the works for about a year. And the main reason for the version bump in Catch2 is that it finally is rebased on C++11. It's been a long time coming, because Catch was first introduced in the pre-C++11 days, and a lot of people still rely on it for pre-C++11 code bases. So Catch2 is really a fork, so you can still get Catch Classic as well. And this has enabled a number of things. A lot of it just internal tidy up with the code base, which is much better for me and other maintainers. But in terms of what users of Catch could get out of this, first feature really was a simple one, little thing, but nice. You can now put commas inside assertions, and it won't interpret that as an extra argument to the macro. This is always particularly frustrating if you had a template instantiation within your assertion, like comparing something against a standard pair of 2 types. Maybe this would be less important with template deduction guides, but still, it's a nice thing to have. And the reason we've been able to do this is because now we can rely on C++11. We've got variadic macros, so we can just capture the variadic macro and piece it together the other side. It just works, nice and simple. I mentioned performance already. With Catch2, we're pushing their work forward. Again, both compile time and runtime. Then this one will take a little bit more explaining. In fact, I'll do a demo in a second. So around Catch 1 timeframe, separated out the commandline parser part of Catch into its own library, which are called Clara, which never quite made it to version 1. For a number of reasons, not least because it was also stuck in C++98. I've completely rewritten Clara for Catch2. It's now at version 1, C++11, but it's also been completely redesigned around the idea of composability. And that's what I'll show in the demo in a second. But I also want to highlight this one. Catch has a new name. It may not be immediately obvious, but a common complaint about Catch originally was that it's very difficult to Google for information about Catch, even in the context of unit testing, because it's such a common keyword in C++, in testing, and so on. So a number of different suggestions were made. I didn't want to have a completely different name, because it would lose some momentum behind the library. But a problem with any sort of derivative name that might still capture the same original searches is then people would still just call it Catch. But I just took the easy option and I went for the second one. So the new name for Catch is Catch2.
But shouldn't it be 1?
Sorry?
Shouldn't it be 1?
No. And to preempt the jokes, yes, Catch22 was a deliberate association, especially if you multiply the 2 by the 11 in C++11. Yeah, fault of all of that. That might seem like a little thing. And as I said, people still just call it Catch, but I'm already hearing from people that finding information about Catch2 is much easier. So it seems to be working. So I've got to do a bit of branding on that. In fact, if you want, I've got some stickers here. I've made new ones with the Catch2 logo. So feel free to come and get those afterwards. And another new feature, it's experimental at this stage. Sorry if you can't quite see it at the back there. Micro benchmarks. So it's experimental, it's not complete, but benchmarking frameworks, the infrastructure around them is very similar to test frameworks, and often you'll want to run them side by side. So I decided in the end to experiment with putting something like this in. So it will do the checking the clock accuracy, will run your tests enough to exceed the clock resolution, and give you enough statistics that you can do your own statistical analysis on it, but it doesn't quite do that yet. So something you can play with, let me know what you think, but we'll see whether I follow through with a fully fledged framework at some point. Now I mentioned I was going to do a demo of Clara. I think I've just about got time. So let's switch off mirroring. Because you may be wondering what it means to be a composable command line parser. So let's go back to our demo we started earlier. Now remember I said that this define at the top, catch config main, tells Catch to generate an implementation in main for you, and also include all the implementation. The alternate version is catch config runner, which does everything except provide the implementation in main, so we can write that ourselves. So again, here's one I prepared earlier. Ooh. We don't need that bit now. Okay. So we've got a main, and in this one we declare an instance of catch session, which is always required. We take the command line arguments passed in, pass them on to the session, check the exit code, and if we're all good, we run all the tests. So as written here, this will do exactly what the default implementation of main will do, but now it gives us some points that we can hook in. So this has always been useful just for being able to put code before and after you run tests, but what we can do now is we can actually grab a copy of Catch's command line parser using the CLI, the command line interface method. And it's an immutable object, but we can, if we made some changes, we could then pass it back like this. So anything we did in the meantime would then be used by Catch. So again, still not doing anything yet, but what we could do now is say, well, let's get a couple of variables, so an integer and a string. So, sorry, let's put that up there. And we want to populate those from the command line. So, just need to bring in the Clara namespace. And then what we're going to do, I said it's composable. So the command line interface object itself is immutable, but I can say I want to compose that using the OR operator, or the pipe operator, with a new option. Let's make it Z. Sorry, before I do that, bind that to the integer, give it a number. And you've got this sort of a little DSL going. Let's make that Y. I'll tell you why I can't use N in a moment. So that will respond to either the -y or the -- number command line argument, and then I can optionally give it a description as well. And then I will also bind that other argument. Let's call that Z, or -- string. Oops. Should be separate there. And again, there we go. So, I took a few seconds to type out, but actually done quite a lot there. We've defined a complete set of bindings for two arguments, including all of the help documentation. So if but let's print that out at the end as well, so we can see that in use. Oops. Okay. So if I build that, okay, so obviously we don't have any values yet. If I drop to the command line, well, first of all, if I show the command line help now, you can see our new arguments there. It's all been nicely handled for us and formatted correctly. We didn't have to do any extra work for that. You can even see the hint strings in there. And now if I say pass y 42, you can see that. And pass the string here. That didn't work because I used the wrong letter. And it would say it. So all handled quite nicely. And all I had to do is just write a few extra lines of code there. So that's what it means to be a composable command line parser. And in fact, if I'd put the CLI afterwards, the Catch's original command line parser, I can actually override Catch's own arguments because it will process those first. And you get to control that. So that's the benefit of the new command line parser in Catch. I'll now switch back to slides to finish up. That's why. No. There we go. Oh dear. Move through this. Okay. So we looked at the past and the present. Quick look at the future. If you've been to some of my previous talks, some of these will be familiar, but hopefully now it'll be clearer why. So one thing I've been putting off for a while is threading support. Because before C++11, without any external dependencies, that was really difficult. So now we've got C++11, that should be probably the next big thing to tackle. And another thing I've been talking about for a while are generators. This is a way of doing data parameterized tests. So you can write one test that will handle multiple different types of data. And then closely related to that, or building on top of it really, is property-based testing. So this will actually generate the data for you. So you just say that I want to test all the integers and it will pick a load of them at random, or you can control it. And then in the event of a failure, it will try and reduce it down to the simplest possible failure. So that's quite an important new approach to testing that I want to build on top of generators. And then closely related to data generators is type parameterized tests. So this is again where you write a single test given a template parameter. You want to instantiate that for multiple template types. And then another big one, which unfortunately C++11 doesn't really help with, is this idea of running tests out of proc. And the reason you might want to do this is if you want to test whether a piece of code actually terminates the program. So if you think about it, you can only really do that if you run it in an external process. So there's not really any support for running external processes in C++11 beyond what we've always had. So that's quite a big chunk of work. But that's definitely still on the list of things to look at in the future. So that pretty much brings me to the end of what I wanted to talk about for now. We'll go to questions in a moment, but I should also point out that all of the references from this talk, even the link to the Flickr page for this photo, are available on my website, levelofinteraction.com/storage/catchrefs.html, or you can find me on Twitter. And if you don't remember levelofinteraction.com, you can also go to extralevelofinteraction.com and it will redirect there. So that's the end of the talk. Thank you very much. And I'll be happy to answer questions, but do speak up because I'm finding it quite hard to hear at the moment. So yes, question there.
Yeah. So would you also talk a bit about weaknesses?
Sorry, let me come a bit closer to you.
I can say it louder. So can I now go home and use this library for some industrial project, or is it not yet ready? Or how it also compares to the other libraries for testing, and are better or on par with them?
Right, so to summarize the question, is it production ready? How does it compare in that respect to other mature testing libraries? I certainly feel that it's mature. Catch, I first pushed Catch to GitHub 7 years ago. almost to the day. Catch2, so it's only been out a month or so now, but really it's just the original Catch cleaned up a bit. In fact, it's probably more stable now than it was before because of all the compiler compatibility code that's come out. There's not really much that's been added that will destabilize it. A lot of people are using it on very big projects. In fact, if you go to the Catch GitHub repo, there's 2 pages in the docs. One for open source projects that are using Catch, so you can actually go and see how they're using the code. Links to their GitHub repos. There's also another page for commercial users of Catch. There's not many on there yet. I think mostly because if you're using Catch or a test framework on a commercial project, you're probably not likely to get permission to actually publicize that. But the ones I have got on there are pretty good. So I've got NASA, I've got Bloomberg, a couple of other reasonably good names on there. So yes, this is widely used, and there's a non-zero number of outstanding issues, but it's basically stable. Yeah.
How do you test Catch?
Very interesting question. How do you test Catch? And I'm actually thinking of doing a whole talk on this because there's a whole can of worms. But basically boils down to 3 prongs. There's a Catch self-test project, which just tests Catch with Catch. And that consists of 2 types of tests. One is where I just exercise Catch itself. So I've got a whole load of things comparing integers, for example. And then the other is what I call introspection tests, where I would actually test internal components of Catch. That can get a bit tricky. If I'm actually changing things as I'm doing this and I break it and then the whole thing stops working. So one nice thing you can do there is you can switch to using a different version of Catch to test the new version of Catch. There's some nuances there, which I'll get into in my talk, but that's the first level. And then the second level is something called approval tests. And the idea behind approval tests is where you've got any code that will log output. And in the case of Catch, basically the reporter output counts. So I just run the self-test code base and capture the logs. I then will diff that against a previous state after doing some pre-processing to remove things that will change frequently, like pointer values. And obviously if the diff compares okay, then everything's good. If it doesn't, that doesn't mean that it's wrong, because it's more like a regression test at this point. If I change something, that may be an expected change. So I can just verify that visually and say, yes, no, I approve that. And now that becomes a new baseline. And that's where the name approval testing comes from. So they're the main approaches, the 2 types of unit tests and the approval tests. But I'll go into that in more detail at some point, I think. Thanks. Any more? Ooh, a few. Over here first.
You said you plan to do something with threading. What are you planning there?
Good question. What am I going to do with threading? And I meant to go into that a little bit more detail on the slide. The main thing that I intend is just to make it thread safe. In that, if you're already in a test case and you spawn a load of threads, and on those threads you then make some assertions, that should just work. That's really what it boils down to. What I'm not planning to do is provide the infrastructure for running whole sections of tests on different threads in parallel. I think that's probably best done at the process level. And in fact, there are external test runners that will already do something like that. So I may do something that will help you divide that up, like going to run the first 10% of test cases, for example. But really, it's just about being able to assert from different threads. And ideally, do that in a way where within the assertion, it doesn't actually take out any locks. So probably by getting where it has to grab a singleton to know where to report to, it will actually get that from thread local storage, and there'll be one per thread. And I had a proof of concept for this working before Catch2. I need to go back to and brush off, but that's really what it comes down to. So, what's the next question? Andreas?
This command line interface, Clara, is that available as a standalone library?
Yes, excellent question. Which I believe I did mention that I'd spun Clara out as a separate library. That is on GitHub. I've moved that to the same organization on GitHub now, created a new one called Catchorg. So github.com/Catchorg, you've got Catch and Clara, both there. Yeah, good question. Timo.
I have a bit of a more philosophical question, and I apologize in advance if this question is totally inappropriate.
No, they're the best types of questions.
So, you had in one of your first slides, you mentioned a few reasons why people don't write unit tests, and one of them was they're too lazy writing them, and then the other one was, I think it's too difficult to set it up, and I don't remember the third one. There's another very common reason why people don't write unit tests, is a situation that happened to me a few times, where suddenly you inherit a project with hundreds of thousands of lines of code, which are not unit tested at all, and which are not written under any kind of design pressure. So what would be your advice for that situation?
It's getting you a job.
That's what I did. But
yeah, right, there you go. So, next question. No, seriously. And it is a very good question. What do you do with legacy code? And in fact, probably familiar with the quote from Michael Feathers that legacy code is any code without tests. Which makes sense if you think about it. And unfortunately, the large majority of code you'll encounter is legacy code. And there's people writing new legacy code every day. So that problem's not going to go away. And there are approaches to dealing with it. None of them are perfect, none of them are particularly nice, but they can get the job done, at least to some extent. In fact, Michael Feathers' book, Working Effectively with Legacy Code, gives a lot of great advice, both in general and some very specific advice, particularly for the C++ world, or C and C++, where there's lots of specific techniques that he introduces to help. But probably the simplest one, at least to understand and implement, is to get some reasonably representative end-to-end tests running. And they might be complex and flaky and take a long time to run, but they'll give you some confidence that as you make changes within the code base to get more code under test, that you're not actually accidentally breaking something at that point. And then there's lots of other techniques to minimize that risk as well. But yes, it is a very good reason why a lot of people give up writing tests, because they're working with that situation. But you can also be writing new code, ideally isolated as much as possible from an existing code base under test, right from the start. So at least you'll be increasing the amount of code under test. What was the last timing? 5 minutes?
5 minutes.
Right, so I've got time for another question. Yeah.
Yeah. Could you tell how easy or possible it is to write tests that you want to run with, let's say, the same test, but with a lot of different data? Is it more or less prepared to put it external in a way that, or you need to always to touch the code? And then if you have tests that you don't know really the output, that you want to do kind of recording test, is it possible with Catch or more or less prepared?
I'll answer the first part of the question first, and I didn't quite catch all of the second part, so maybe we'll come back to that. But so the first part, I think, was about the data parameterized testing, which isn't currently in. There was an early version of it that basically worked, but unfortunately didn't work with sections. And the reason is that both features require rerunning the whole test case, but they weren't in sync with each other, so they just trampled over each other. So I spent quite a lot of time rewriting the section running code to actually allow for other things that would hook in preparation. But when I started actually writing the generators code, I was getting so bogged down with C++ 98 syntax, so I'll put it off until Catch2. So I just need to come back to that. So there's still work to be done, but I've had a proof of concept already. There is a way of faking it for now, which is you can run sections either in a loop or by calling it within a function. And the trick is you have to make sure that the section name is unique on every instantiation, or every time you run through it, by combining the section name with, say, a loop counter or something from the data. And that will allow you to achieve something like that. What was the second part of your question again?
The second is maybe more intended for integration test. When you, for example, you don't really know the output data, or the output data it can be more complex, and if you have kind of way for recording, is this way it's like, okay, you want that it match, you don't know exactly how it looks, but you know that now it's okay, you want to record this, and then you want to check that every time it's the same, and when it fails you verify if this had to check to fail or not, and then you record again. Yeah, so this is to do with integration testing, you said, where you don't really know what the output necessarily is going to be until you run it. And this really feeds into what I was saying about approval testing, which isn't specifically a feature of Catch, at least not at the moment. But this is where you will dump the output somewhere, maybe to a log, and then do the diff of the log as you're testing. And that way you can visually inspect it and approve that's what I actually want, and that you know when it changes. And in fact, there's a whole suite of tests called approval tests. And the guy that maintains that, Llewellyn Falco, actually contacted me just a few weeks ago because he wanted to build a C++ version on top of Catch. So that's actually coming to C++ as well. So I should put that in the refs, really. That'd be quite interesting. So, does that answer your question? Yeah.
Do I have time for one more? Or One more? Is there another one? Yeah.
Another philosophical question.
Okay.
Do you know of any good reason why a unit test framework is not part of a C++ standard library?
I think, as with anything to do with the C++ standard or standard library, if something doesn't exist, it's because nobody's proposed it or managed to push a proposal through. And I have had this question a few times over the years. You know, what I put Catch forward for standardization. I don't think Catch itself, at least as it currently stands, would be a good fit, but maybe something like it. And we have boost test, and boost feeds into the standard, so maybe something like that could. There may be more appetite for it now that standardization process is moving along more quickly again, but it's not something I'm actively pursuing myself.
So you're not pursuing that in any way?
Not currently, but with the right motivation, you never know. It's an open question, I think, but that's really the only reason it hasn't happened yet, I think. And I suppose that is a big, it's not like a one-line change in the standard. It's really quite a few pages.
That would maybe probably solve the first philosophical problem. I mean, if there is a out-of-the-box, out-of-the-shelf available unit test framework for everyone, then people will maybe start, with writing tests.
Yeah.
So wouldn't that at least increase the probability that?
Is there one size fits all?
Yeah, I don't know. But this would be a practical question for the standard committee. Like, go on, guys, and try to kind of view with that, and because that would be a very practical addition to the.
So if you're getting philosophical, there are different trade-offs between different frameworks as they exist, and there is actually a very, very minimal test framework that is already built into the standard. That has a lot of trade-offs, but it's just called a cert. And you can actually get surprisingly far with just that.
Yeah,
so,
that usually misses that you need to write your test on your own.
Yeah.
So and that is of course a big problem. I mean, because you need to kind of make sure that it actually compiles, and you link the proper libraries and do all the stuff which is required to set up a C++ program, which might be non-trivial for many kinds of applications. So if you had something which is already built in, and you just say, okay, like create a specific some kind of special application, and well, includes and pull in some headers, then that would be I guess that would be a great addition to the standard. I would like be ready to compromise. I mean, it would not have to be perfect, but it would just work out of the box.
There'll definitely be value in it. I think if anything happened at all, that would probably happen once we've got some form of reflection, because it'll handle a lot of the current complexity in most test frameworks in a much simpler way. So I'm seeing that the session is now over. So thanks for all your questions and for listening.